Hello everyone. I got uh, I got my script ready, so here we go. Okay. I just yesterday I made a video, another video in the series of the smoking gun, right? Well, now nobody understood what I said in that video, so now I gotta do a little damage control. Basically, somebody said, well, y- you know, I said in the last video that three cannot be divided perfectly into 10, and somebody in the comment section said, uh, well, basically somebody in the comment section said 1/3 times three equals one, and you know 1/3 times three divides equally into one, and that's how I know that nobody understood my last video because in the last video, I literally said that 1/3 is one thing divided three ways. Now, I know I'm going to get, I basically I was saying that 1/3 times three it goes equally into one. 1/3 times three equals one. That's basically what I said. Now I'm gonna get 20. I'm gonna get 20 comments saying, you didn't say that exactly. You corrected yourself. You know. Um. But the point stands that I said in the last video that 1/3 equals one thing divided three ways. So obviously 1/3 times three equals one. But what I said after that was that 3 does not divide equally into 10, or in this case, 1. You you say, okay, I'm going to divide 3 into 1, and then you say, how do I do that? Multiply it by zero point 0.3. Zero point 0.3 times 3 equals zero point 0.9. Now, uh, after you have the zero point 0.9, you say, okay, is it equal to 1? No, there's a zero point 0.1 left over. So you have to divide 3 into oh 0.01. I'm sorry, you have to divide 3 into zero point 0.1. You have to divide 3 into zero point 0.1, which would be 0.03, and then you're left with a zero point 0.01. You're left with a zero point 0.09 divided into zero point 0.1, which leaves a zero point 0.01. And that continues. But, that, to skip to get to the point, that's a proof against infinity. Why? Because, you know, you keep having to, divide 3 into 1, and you're always left with the one left over, which means that no matter how many times you multiply by 3, even if you would multiply by 3, even if you were to multiply by zero point 0.3 infinity times, you would always have a 1 left over. So in that sense, zero point 0.3 is not 1/3. So let's decouple those two arguments. One thing divided by 3 into 3 parts equally is not zero point 0.3. Uh, zero point 0.3 infinitely is not zero point 0.3 infinitely, because no matter how many times you multiply by zero point 0.3, you always have that one left that that point 0.1 left over. And in that sense, it is like in that sense, 0.333 is like infinitely not infinite. Why? Because you are infinitely not at 1/3, as in every time you divide it out, in every situation, you will always get less than 1/3. You see, and that gets to the whole irrational numbers thing. Is that no matter how many digits you add to it, you will never perfectly reach pi, as in every in a sense, every digit is wrong. Why? Because it does not terminate. If the digits were right, they would terminate at some point. But even pi itself is just the closest human approximation of a circle. It is not a perfect circle because no matter how many digits you add, you will never perfectly hit pi. In that sense, in a rational number is just, you know, infinitely wrong. No matter how many digits you add to pi, you will never perfectly reach that circle. Even if you were to add infinite digits, you would not reach a perfect circle. So in that sense, it sort of disproves infinity. You know, because you are infinitely getting the wrong answer. The first digit, is higher than the circle. The second digit is lower than the circle. The third digit is higher. The fourth digit is lower. You know, you were never perfectly hitting pi. And it could be that the problem is with the base 10 number system. Maybe we need to have a higher number of numbers, a higher base of numbers or a lower base of numbers, in order to reach a perfect circle. I mean, I haven't seen that would be a good experiment to have to see if we had if we could do higher base, lower base to try and reach pi evenly. But I mean, that's probably been done. That's probably been attempted many times. But yeah. So I mean, uh, and then somebody said. Then somebody said, you can't store you can't store infinite numbers, uh, which you know somebody said you can't store infinite numbers, and that but to be fair, they said you can't store infinite numbers, but they said that doesn't mean infinity doesn't exist. What I was saying is that it what what I was saying in all fairness was that the fact that infinity itself cannot be observed, as in the fact that you cannot see the movement of infinity, the fact that you cannot see, the fact that you cannot, the fact that nothing is infinite, the fact that there's nothing observable or verifiable uh, in existence which is infinite. Uh, uh, so I mean, I guess that's the problem, which is that people are saying that things exist even if we cannot observe them or verify them. But uh, I'm saying the opposite. I'm saying that if it cannot be observed or verified, then it would be unscientific to say just take my word for it. You know, so and um, and the irrational numbers, really demonstrate what I'm saying is that you cannot you cannot count out the irrational number to infinity. So infinity itself is not observable. You have to stop. You have to round it off at a very low point. that's my point. Is that you cannot continue to infinity, and the whole thing with the triangle with the two 1 inch 1 inch legs and the hypotenuse is the square root of two. Well, that is not infinity because it is it is it is predicated on the limits of the measuring capabilities and the display capability of the paper, as in, like, you in order to actually draw it out on paper you have to round it off. You cannot, you know with paper you have a certain number of grains per inch. Basically you have a certain number of atoms per inch, and you have to cover certain atoms or you have to leave certain atoms blank. But you cannot uh, have part of an you cannot draw a line that goes to infinity. You have to round it off by purely by nature of the way that physical objects are built. As in, you can only get as small as the size of an atom. You cannot, you cannot do like uh, 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 a fraction of an atom. You cannot draw to a fraction of an atom to infinity. You have to round it off, and that was my point. Is that nothing we have is infinite. We cannot show infinity. So this is called damage control. I know I'm going to have a whole lot of more damage controls. Uh, so but it's the summer's getting really hot. And you know what that means. So stay cool. Drink a lot of cold water. Uh, you know. So I personally don't like AC, but you know how it is. And uh, yeah, just have a nice day. Bye.